Thank you. Good afternoon. My name is Leander Yu, founder and CEO of Great Technology. So today, we're going to talk about how do you transform your infrastructure into an AI-ready infrastructure for your AI workload. First of all, we will talk a little bit about the introduction about Great Technology and introduce our partners and our recognition around the world. And we will demonstrate some of the hardware that was certified with us, especially from some of the partners with us. And then we will talk about one of the use cases that are using our solution together with BGFS to deliver unprecedented performance for your AI workload. And later on, last but not least, we will introduce another partner that provide the AI cloud infrastructure for your AI applications. So in that case, from hardware, middleware, and the application layer, it's a total turnkey solution. So first of all, let me introduce Great Technology for a little bit. Great Technology was headquartered in Silicon Valley. We have R&D center in Taiwan, Taipei. Before we started this company, the team was very focused on software-defined storage. Actually, I was the founder and CEO of a software-defined storage company working on software-defined storage solution for data centers and telco customers. So we know every technology that those large-scale customers or large-scale data center would need for their workload. That include AI, machine learning, and big data analysis. So most people would ask me a question when they know I start another company called Great Technology. They will ask me, why do you need to start a company working on RAID solution? Because RAID solution has been in the market for so long, and nobody can remember why we still need RAID, because it's already there, and nobody cares about that anymore. However, we see something change, and that's why we start this company. So the answer is very simple. Why we start this company? The answer is because of NVMe SSD. So when we do the, back in 2017, when we start to see customers start to use SSD into their software-defined storage solution. And it started with using SSD as a data cache layer. And later on, we see more and more SSD was used for the data storage. And we quickly find out that if you want to drive all the performance of the SSD using software, it's impossible. I use the word impossible because that's really impossible. We try everything we can. We were in software industry for more than 20 years, and still we find no solution that you can drive SSD performance by using software. So it's like a nightmare haunting me every night. Every night I wake up, I see a news saying that, oh, there is a faster SSD come out. I was like panic, right? So later on, my previous company was acquired by an SSD company. And at that time, we learned a lot of technology about SSD. And turned out, eventually we find a solution. And that's why we started technology. So as for now, technology has become the most powerful RAID solution in the world. We deliver the most powerful RAID solution to the market. And quickly, we got so many recognition from the market. Every year, we got so many awards. We got a CRN award, we got a CS award, we got Fresh Memory Summit Award. So every year we got so many awards because of this innovation. And this innovation totally changed how do you use NVMe SSD and the performance you can get from the SSD, and also the return of investment of NVMe SSD make sense to most of the buyer. So with all this software knowledge and the SSD knowledge, that's why we can deliver this kind of world-class and state-of-the-art product to solve the NVMe SSD bottleneck. So very quick, we got so many recognition from our partners like NVIDIA, Intel, and AMD. And we have so many OEM server customers working closely with us to certify our solution within their servers that can boost their NVMe performance to 5 times and 10 times. We work very closely with those SSD vendors, including Samsung and other SSD vendors that we help them to deliver their performance to their customers. Because every time when their customer purchase their SSD and their SSD saying that we can deliver this kind of a performance, and customer will ask, what happened if I have RAID? What happened with my software-defined storage solution if I use your SSD? And right now, they have a solution that can deliver full potential of their SSD. And quickly, we have all the distributor, all the channel sales, partners worldwide to sell our product to the end customers. So we have tier 1 distributor in US. We have distributor in Korea together with Grusys. And we have distributor in Japan, Southeast Asia, and also Europe. So today, I would like to introduce one of our partners that developed a very unique hardware platform for us to demonstrate our performance to you in this event, which is Gigabyte. This is one of the sample hardware that provided by Gigabyte. It's OCP certified. It's a very unique 2U 2-node servers, and each node they can have 12 E1.S SSD. So that means in this 2U form factor, you can have 24 NVMe SSD inside. And each node was powered by Ampere ARM CPU. So this kind of server is perfectly for your AI, machine learning, and also HPC and cloud computing, especially for those use cases that you require large amount of data analytic because of the density of the SSD. So this is one of the samples that provided by Gigabyte. But today we are going to focus on this specific model. It's a E1 servers that equipped with 32 E1.S SSD. So this is a very powerful model that will be able to provide this kind of a density and deliver very high performance. This is the Gen 5 servers with 1U form factors, 2-socket Intel SSD, Intel CPU that allow you to equip 32 SSD. And this is also the server that we demonstrate in our booth. We have a hands-on booth, so you can have your hands-on access this very powerful machine. Unfortunately, right now, we don't have Gen 5 SSD because Gen 5 SSD is still in a very early stage. So right now, we equip with 32 Gen 4 SSD, but still, with 32 Gen 4 SSD, it still can deliver very good performance. So with this kind of a server, if you were using Gen 5 SSD with great technology, so this is the performance number you will get. And most people see this number will believe that, well, this is impossible because this is faster than a PCIe slot, PCIe Gen 5 by 16 slot. So this is what makes great technology so unique. Because we have a very unique technology that can solve the bottleneck of the rate controller card. So you might wonder, how can we solve this problem? So simply speaking, we have two unique technology. The first one is that you will see our car. You might believe that it's a proprietary highway rate controller card that developed by great technology. But if you look at closely, you will find out that it's actually a GPU card. It's an NVIDIA GPU card, right? So great technology didn't produce any hardware. Great technology is a software company. We have a very unique software that runs on top of NVIDIA GPU card. And using the computing power of NVIDIA GPU card, we can process all the I/O coming from SSD. No matter it's Gen 3, Gen 4, Gen 5 SSD, we have the full potential power to drive all the I/O. But you might ask, if you run your application on a GPU card right now it is a Gen 4 by 16 slot, right? So if all the data has to go to this card will become a bottleneck. So the most best throughput you can get from a Gen 4 by 16 slot is somewhere around 25 gigabytes per second. So how can you get this number? So that's another unique source we have. And you are very lucky today to hear this unique source. We have a patent technology that we can do RAID data protection out of data paths. That means not all the data has to go to the GPU card. Most of the data will be transferred directly from SSD to your system memory. So that's how we get this kind of performance. So this performance is a RAID 5 or RAID 6 performance. It's not a RAID 0. If it's a RAID 0, getting this kind of performance is quite easy. But this is RAID 5 and RAID 6 performance, right? Right now, no one in the world can get this kind of performance. And you will see, you will get this kind of performance out of a single server, one use server, you will get this performance. So let me share a story with you that couple years ago, about 5 years ago, we are working on a customer who want to build a storage for AI. The requirement is this storage must deliver 66 gigabytes per second throughput. And guess what? How much money did they spend for this kind of storage? They spent $2 million US. And totally they need around 60 nodes, 60 nodes to get this kind of a performance. But right now, with one single node, one use server, you can get this kind of a performance, 220, compared with 60 gigabytes, $2 million US, 50 nodes. That's amazing, right? But next, we want to move one step further. If you have this kind of a weapon to deliver this kind of performance, how do you use this in the real world? In the HPC or AI environment, usually you need a distributed file system to store all the data. So all of your compute nodes will be able to access the same data set. So they can do their own analytic for the same data set. So usually they require a shared storage or distributed file system like BGFS or CephDay. So today we want to share with you a reference design with BGFS to demonstrate how can we improve the performance of BGFS. So with this configuration, we have 2 data nodes and 4 clients to simulate the real environment. So each data node will be protected by RAID 5. So each data node would have 2 RAID 5 groups. And that means you can have 1 SSD fail in each node without impact any your data. And with these 2 nodes, from storage node perspective, it has capability to deliver up to 130 gigabyte per second throughput for read and 77 gigabyte per second throughput for write. And it's in RAID 5 configuration. However, this kind of a distributed file system, it requires you transfer data through the network. So in this configuration, network has become a bottleneck. So right now, each node we have 200 gigabit network. So in total, we have 400 gigabit network for this configuration. And from the result, you will see that we can saturate the entire 400 gigabit network, so you can get a 40 gigabyte per second read and write performance, right? So in this kind of a reference, each node, you will be able to get 153 terabyte available space. And if you have 2 nodes, you will get almost 400 terabyte available space. Right. So if you need more space, you can add in more nodes. By adding more nodes, you will also get better performance. So right now, 2 nodes, you will get 40. If you have 3, you will get 60, and so on and so forth. This is the topology we use for this testing. So as you can see in the screen, we have 2 physical nodes, and each physical node we have 16 SSD, and those 16 SSD we divide into 2 groups, and for each CPU they will manage a SSD. And because BGFS require metadata, so those 8 SSD, we allocate 2 SSD for metadata and 6 SSD for real data, for user data. So that means we have 12 SSD for user data on each node. And if you have 2 nodes, you will have 24 SSD for the user data. So that's a configuration. And each node we have Supreme RAID installed on one of the under one of the CPU, and we have a network card, which is a dual port 100 gigabit network card connected to another CPU. And we have 4 clients connect to these 2 nodes, also by 100 gigabit network. So this is the configuration we do the test. So this is more detailed hardware spec for the server node and client node. As you can see, the server node is provided by Gigabyte. Totally, we have 2 servers. Each server has 2 CPU, and we have 16 memory. 16 memory for each node. We have 16 SSD for each node, right? And from the client, it's a 2U4 node servers, and to simulate 4 clients simultaneously read and write from the storage node. So this is the result, right? Theoretically, we should be able to deliver 130 gigabyte per second throughput for read and 77 gigabyte per second for write. However, because of the network bottleneck, we are using a 400 gigabit per second network card. So we still get a very good performance. It's pretty close, pretty much close to the theoretically throughput we can get, which is 45 for read and 42 for write. And this is coming from 2 nodes, right? So this is the best performance we can see in the market. Right now, usually you need 4 nodes to get this kind of performance, but we can get it by using 2 nodes, right? And we have some detailed benchmark parameter here, because usually when you do this kind of benchmark, especially for NVMe SSD, there is something you should be aware of, especially for SSD, because of the performance of the NVMe SSD is way faster than hard drive. So usually you have to bypass the caching layer, the operation system caching layer, in order to get the full potential of the performance out of SSD. So you can see here in the benchmark parameter, we will use the I/O, because if you didn't use the I/O, the caching layer of the operation system, from operation system, will slow you down, right? Because right now, I have to tell you that operation system still cannot catch up with the performance of SSD. So you have to use the I/O. So by using the I/O, you will see that from the right-hand side, you will see if you have more and more clients, you will reach the optimal performance of the storage node, right? So it's a pretty simple concept. Many people, when they are benchmark SSD, if you use only one client, you will not get the full performance of SSD, because SSD right now was composed by so many flash DIMM. So you will need 4 or even 5 clients or even 10 clients before you can get the optimal performance of SSD. And for us, because we aggregate more than 16 SSD, so that means you need to create enough workload in order to saturate this kind of a performance. So as you can see, the performance reached to top at 128 clients, right? So that simulates the real workload of your AI application. And what's the next? When you have your GPU server, when you have BGFS distributed storage that can provide this kind of a huge data performance to your workload, and what do you need next? The next is that you need an AI stack to help you or help your developer to produce the generative AI workload. So together with InfinitySoft, we help our customer to pool their GPU resource and provide the GPU resource on demand for their applications. This solution has been widely adopted by so many research institutes and also some research and economy or education industry, that they require a lot of GPU resources, but they have very limited physical resource that can provide to those even students or their employees. By using AI Stack, we will be able to aggregate those resources together. You will be able to divide one big GPU into so many small pieces and allow your client to use those small pieces GPU as their own GPU. So this very unique solution bundled with our great technology, RAID solution, and Gigabyte hardware, we will be able to deliver a turnkey solution for not only IT, but also for those school or economy. Okay, should you have any question, feel free to ask, or you can go to our booth. Right now, we still have hands-on sessions, so you will be able to experience this kind of a high performance by your own. You can do your own test. You can feel how performance would look like in a server like this and with great technology RAID solution. Right, thank you. Any question?
네, 열심히 발표해 주신 린더 유님께 마지막으로 박수 치면서 네, 감사의 의미로 네, 감사합니다.